Hey guys, Mr. Parsons here with another homework help video. In this video, we're going to be doing solving quadratic equations from 9.4. We're going to do part 3 and 4. On a previous video, we did 1 and 2, which covered solving the equations by using the square root property, wherein you'd get basically x squared by itself, or something in parentheses squared by itself, and then you'd undo that by square rooting both sides, which would allow you to solve for x. And the results typically had two answers, but I did try and show you near the end of that video what would happen if you had one or maybe no solution. On this video, we're going to be doing a little follow-up to the part 2 from the previous assignment. The part 2 was using this zero product property, which says you need to find out what goes into each parenthesis to make 0, and therefore that's the answers that make something true. The problem is on this assignment, and I will show you on the first problem right here, is you need to use the zero product property, yet there's no parentheses to use it on. So what you're going to do is you're going to make parenthesis sets to use it on two binomials, just like we had on the last one, by factoring it. So for the first bit here, we're going to factor these and use that to help us answer the question. So let's jump right in. So we got b squared minus 4v minus 21 equals 0. So the way you want to solve this is, now, just so you know, how do you tell the difference between something like this and something we saw previously? On the previous one, we had just x squared by itself, or we had something plus one other number in a parenthesis being squared, but no other variables otherwise. Like the variable appeared in one place, which is good. Now, when we got to the end of the assignment on the previous one, we did see variables in a couple places, and we did factor it. We did like basic factoring, where we divided like what can I divide out of each thing? Like we divided out 3 from each of the terms because there was 2 terms. The problem is you can't divide something out here, and you can't move 21 to the other side because that'll just leave you with some v's over here. You can't really have v in 2 places unless they're in their own parentheses. So here's what we're going to do. We're going to factor. It's been a while since we've done factoring, but the way we did it was we made this big X to help us organize it. The end number goes on top, the middle number goes on the bottom, and you have to think to yourself what multiplies, put a little multiply sign there to make 21, yet adds to make 4, negative 4. And I mean, you gotta work it out. You might have to do a little guessing and checking, but the answer here is negative 7 and positive 3. They multiply to make negative 21, yet add to make negative 4. And therefore, by that logic, I can write this as v minus 7, v plus 3. So basically what I've done is I've taken the original equation, the left side of it, and I've turned it from this trinomial with the 3 parts into 2 binomials. What's the purpose of doing that? Well, now that it's like this, I can use my zero product property we practiced in part 2 of the previous homework that says, what do you plug into this to make 0? What do you plug into this to make 0? Now here's the deal. These ones are so simple, you should really just answer them without writing work down. Like, it's just like, what's the opposite of negative 7? What's the opposite of positive 3? But if you want to set them each equal to 0, and then do the work to both sides, that's totally okay. You'll still get the same answer. You get 7 and negative 3, which were the opposites of the things up there. Anyways, and that's the answers. 7, comma, negative 3. So again, the process was we factor if we can, and we can, and then by having it factored into these two parentheses, we're allowed to use that zero product property to help us quickly decide what goes into each parenthesis to make 0, and therefore answers the question. And there are 2 correct answers. If I had plugged in 7 to the original equation, or I plugged in negative 3 to the original equation, both would result in the left side equaling 0, which is what we wanted. Let's try that again. b squared plus 5v minus 6 equals 0. So I make a big X, I put the last number on top, the middle term b on the bottom. What multiplies to make negative 6 yet adds up to 5? Careful, you might be very tempted to use 2 and 3. However, it is 6 and negative 1. If you use 2 and 3, it'll make 5, but it won't make negative 6 when you add positive 2 and positive 3. No, you gotta be careful. Some things are tricky. They have like 2 really close looking ones. Okay, anyways, this means v plus 6 is in one of the parentheses and v minus 1 is in the other parenthesis. And then just like before, you can set them each equal to 0, but again, I'm telling you, especially on these simple ones, just write the reverse, or the opposite, I should say. -6, +1. Because plugging in -6 into the first one would make 0, and therefore the whole thing would equal 0. And plugging +1 into the second one would make 1, 0. 1 minus 1 is 0, and then that would be 0, and the whole thing would become 0. These ones are pretty quick. The key thing is you have to remember how to factor from what we did in Chapter 8. All right, this one's a little bit different. They're switching it up on me here just a small bit in two different ways. Number one, not everything's on the same side. That's not good. You kind of want everything on the same side. You want it to equal 0. You can't factor with stuff on both sides. Well, I guess you could. It's not something you want to do, though. So here's what I'm going to do. First step, we're going to subtract 6. So we get 13v minus 6 equals 0. Okay, now here's problem number 2. On all the examples we've seen so far, there wasn't a number in front of the v squared term, the first term, but here there is. That changes things on how we solve this. So what happens is, instead of writing -6 on the top, it's the first times the last. That's technically what we were doing the whole time. We just didn't really bother to think it out because the first number was always 1. And -13 is still on the bottom here. So what multiplies to make -30, yet adds up to make -13? Another tricky one. It may seem really tempting to write 10 and 3, but 10 and 3 is wrong. It's -15 and +2. It's the only way to add up to make -13 and multiply to make -30. A -10 and a -3 would make 13, but it wouldn't make -30. All right, now we've split it. Now here's the thing. This is not the answer. So we have more problems because if you recall from previous stuff we did this year, when there's a number out front and you get these two answers like this, you can't just write v minus 15 and v plus 2 like we had done in the past. That's wrong because of this number out front. So there's two options. If you watch the video on the lessons, the option Mr. Steiger presented, I believe, was to put it in the boxes. So you put 5v squared for the first thing. You put -15v and 2v, the things we split up from the sides here. And then -6 goes last. And then you have to factor out, like, what can I divide out of each row and column? So the first row is both divisible by 5v, because 5 and 15 are divisible by 5. And they both have a v. The first... well, the second row, let's do the second row. 2v and 6, they're both divisible by 2. The first column is only divisible by v. They only have a v in common. And the second column, they're both divisible by 3, specifically -3, because they're both negative. What I like to do is do this out with the numbers and then try and figure out the signs out at the end. Just make sure it works. Does 2 times -3 make -6? Yes. Does 5v times -3 make -15? Yes. Then things are looking good. Okay, that allows us to write the answer as 5v plus 2. It's not really the answer yet. V minus 3. All that equals 0. All right, so here's what we've done. We had the original. We moved the 6 over. Now we had to factor it. We had to factor it a little bit special because it had that number out front. And then we used x to figure out the two things to split. We put it all in the box. We factored out of the box. We've got this right here. And we're not done. We have to find out what things go into these to make 0. So I'm going to show you the speed way. Again, the opposites. V equals 3. That's the opposite of -3. It's trickier when you have this 5v plus 2. You're going to write -2. That's the opposite of the 2. Over 5, the thing that was with v. That's how you do it the fast way. So again, the trick is, if you want to get these slightly more complicated ones answered faster, the opposite of the lone number, -2, over whatever thing was multiplied with the v, 5. If you're not confident in that, just work it out. It's fine. There's your two answers, though. -2/5, 3. Now I'm going to present something to you here. It's an alternative method. If you were in my class, you will have seen this. I'm going to write it in blue so you know it's a little bit different, okay? This is alternative. This is called bottoms up. The way you write bottoms up is you attempt to write the answer like you would have doing the normal process. V minus 15, V plus 2 equals 0. except this isn't right. I mentioned earlier it's not right, and it's obviously different from what we had as our actual answer, right? So in the bottoms up method, what you do is this. If there was a number in front, 5 in this case, you divide each of these things in the parentheses by 5. So v minus 15 over 5 becomes v minus 3, because 15 divided by 5 is 3. On the second one, though, you can't reduce it, and you can't simplify it, and you can't divide 2 by 5, so you bring the bottom up in front of the v, plus 2 equals 0. And you look at that. That's the same thing we got right here. So it's kind of up to you how you want to do it. If you want to do the bottoms up way, it's a little bit of like voodoo, but you put the two numbers, you put the leading coefficient 5 underneath it, divide it if you can, bring it up if you can, and that magically results in the answer for reasons. Or you can make a box and factor it out. I think they're both fine. I'm not saying one's better over the other. Bottoms up definitely tends to seem faster for people. Whew, okay, let's take a break from that. Back to the easier ones. How do I know it's easier? Because there's no number in front of x squared. When there's no number in front, you can just, write the x, factor it, and call it a day. No special first times last. Although if you always want to think about first times last, that's fine. It's like 1 times negative 14 is negative 14. 5's on the bottom. And the numbers that multiply to make negative 14, and add up to 5 are 7 and negative 2. Almost put a negative on the 7 there. And therefore we can write x plus 7, x minus 2 equals 0. And then we use the zero product property, so the opposite would be negative 7 and 2. Done. My goal is, especially if you're watching this, that after you've done the first 3, you'll be able to do 4, 5, and 6 kind of okay. It's a repeat of the first 3, so 1 and 2 are the simpler ones, and I believe 4 and 5 are also simpler ones. Yes, 5 looks like that also. And 6 will be another one of those number out front, more difficult, got to do the works kind of stuff. Okay, do an x. What multiplies these? When you multiply these, what do you get? You get 30. 11's on the bottom. 5 times 6 makes 30, yet adds up to 11. U plus 5 times u plus 6 is the factored form of that expression. And then the opposites. Negative 5 is an answer. Negative 6 is an answer. Good stuff, right? All right, another difficult one. Ooh, look at this one. They're even getting more spicy on me. 2u squared, negative 5u minus 2. Now, on the previous slightly advanced example, we had to move it all to one side. And what we did was we moved just the single number over to the other stuff with the letters. Here, we have 2 things on the right and 1 thing on the left. I would leave the left the way it is. Never let the squared term be negative. That's just asking for a problem. So 2u squared is positive right now, so it should stay where it is. It's better, I know it's more work slightly, but it's better if I add 5u to both sides. And then I get this stuff. Then I should add 2 to both sides. 2u squared plus 5u plus 2 equals 0. Sorry, that's just the way it's got to be. You could probably save one step there if you just want to add the 5u and the 2 at the same time, but I wrote it out. It's fine. All right, now for the process. So process is 2 times 2, 4. Bottom number's 5. What multiplies to make 4 but adds up to 5? 4 and 1 multiply to make 4 but add up to 5. Okay, again, you can do the box, or you can do the bottoms up. I will show you the bottoms up first, just so you can get a feeling for how speedy it is. I write u plus 4, u plus 1. This is not right, but I correct it by putting each of these over 2. Why am I choosing 2? Because that was the number in front of everything here. So I get u plus 2, and then on the second one I can't divide, so I bring the 2 up and get 2u plus 1 equals 0, and it's factored. Okay, if you're like, no, I don't like that. Okay, here you go. You can do a little box, and instead you can write 2u squared, 4u, 1u, and 2, the numbers from the first and last in the splits. And then I can divide out of this one 2u, I can divide out 1, I can divide out u, and I can divide out 2. And what do you know? It gets me the same answer, 2u plus 1 and u plus 2. Now, regardless of which way I do it, I still need to write the answers, which will be the opposite, negative 1 over 2 for this first one because of that weird number up front, and negative 2. Oh, that wasn't a very good negative 2. From the second guy, it still doesn't look that great. Hold on. Let's make it more beautiful. Negative 2. There we go. It's a lot of steps. What can I say? So I had to move it all to one side, and then when it was in that form, I had to make the x, put the right numbers in it. Here I had to be extra careful because it had a value for a in front of the u squared that I needed to appease. And then I wrote both methods. You don't have to do all this work, but I showed how to do bottoms up by writing the 4 and the 1 and putting them each over 2, and then bringing the bottom up if it didn't divide. Or you can do the box. You don't have to do both. I'm just showing you both. On to some new problems. I think. Yeah. Okay, so the next set of problems are from part 4 of the lesson. These ones were you were writing an equation. Now, when we were doing the lesson, I have to admit that these problems don't exactly line up the way they did in the lesson. And I'm sure you're so sad to hear that, but the lesson ones were harder than these. These ones are quite easier than the lesson. On the lesson, what happened was there was a graph given, and on the graph you could see where the zeros were, and you had to say, oh, this is 0 comma negative 2 and this is 0 comma 5, and then they gave you like the vertex point up here and said, okay, this is like, oh, I have to wait a second, I got to do math better. Negative 2 0 5 0, and then I don't know, the vertex here is like 3. I didn't use numbers good. Okay, 3.5 comma 2, whatever. You got 3 points, right? You got 3 points on the graph, and you had to use those to make the equation. And you made the equation by, I'm giving you a quick rundown here. You would write x plus 2, that's the opposite of the 2. You would write x minus 5, that's the opposite of the 5. And this is kind of right, except for this doesn't account for the vertex being specifically at 3.5 comma 2. So what would happen is you would take this is a, you'd have an a out front, and what you'd have to do is plug the vertex in for x and y, and then solve for a, and then use it to write the full equation. That's a lot of stuff, right? So you'll be happy to hear this is easier on our homework. In fact, I don't even need the paint here. It just says, write a quadratic function whose zeros are 11 and negative 3. So it's kind of like the picture example I showed you a second ago, except for here they're not giving you a third point of the vertex. They're just saying, write a quadratic function whose zeros are 11 and 3. You'll be happy to hear there are infinity different quadratic functions whose zeros are 11 and negative 3. So all you have to do is write x minus 11, x plus 3. That's it. If a 0 is 11, that would have gone into x minus 11 to make 0, right? And if one of the zeros is negative 3, then x plus 3 would be go to the big 0. Now, you could put a number out in front of this, and it would be right. I don't know if I'm gonna do it. I'm gonna test it for your sake. This could be wrong. Let's see what Alex says. Oh, it liked it. Okay, I put a 2 out front like randomly. You can put any number out front, in my opinion, and it should be right. Like there's nothing, you can put any value for a and you won't be wrong. The reason why it's different from the lesson, because on the lesson, they gave you a third point that it had to go through and you needed a very specific a. Here it doesn't bother telling you you have to adhere to that. So you could put any a value. In fact, I didn't even have to write 2. I could have just wrote the parentheses and called it a day. And even further on the lesson, I believe that Mr. Steiger demonstrated how to distribute this out and write it in standard form. As you can see, Alex was quite happy that I wrote it in this factored form and didn't even care. So as long as you're making sure you write those zeros. So on this one, let's go do it quick. X plus 2, x plus 9. Those are the opposites, right? Negative 2 makes 0 here. Negative 9 makes 0 there. You could put any number out front, but I'm not going to put any number out front. And it's happy with it. Just like that. All right. This one is spicing it up just like this much extra spice. So here's what it says. It says, write a quadratic equation whose roots are 6 and -5, same as the zeros from the previous problem. And then it adds this, and whose leading coefficient is 5. Oh, they want a specific a value. But unlike the lesson where you had to like plug stuff in and find the a value, here they're telling you the a value. The leading coefficient is 5. That's the a value. So here's how you write it. A value, and then in the parentheses, those opposites. X minus 6, x plus 5. That should be good. I mean, this has the root of 6, it has the root of -5, and it has a leading coefficient of 5. If you distributed it all out, you would see like 5x squared plus minus this, minus that, or whatever. And if you want to do that, you can, but I think factored should be okay. Yes, Alex was okay with the factored version. So same situation here. Leading coefficient is 4. Okay, so 4. The roots are -3, so x plus 3. Make sure you write the opposite. X plus 2. Awesome. All right, that's it. We did it. Submit assignment. What time are we at? 21 minutes. All right, shorter than the last video. We'll go to the report here. I'm going to talk to you about some stuff, and if you're still watching the video, holy moly, good. I'm going to add something at the end here that will ruin this a little bit for you. But if you're watching it, it's news for you, okay? So hopefully you stuck around. Let's talk about the lesson real quick, though. So on 1, 2, 3, 4, 5, 6, we had problems where we needed to find the solutions, and we needed to use the zero product property, but we had to factor first. So 1 and 2 had basic factoring. 3 had one where there was a coefficient in front of the squared term, 5 in this case, and I had to move all the stuff to one side, and then we had to factor it, and it was a little more complicated because that's just sometimes the factoring's a little more complicated. So we repeated that on 4, 5, and 6, 2 easies and a advanced one. And then on 7 and 8, we had problems where we were supposed to write any function who has these zeros, and you could put an a value up front if you wanted to, or you could just write the factored parentheses, and that's good, I guess. On the last two, it said write an equation whose roots are as follows and has a leading coefficient. So we wrote the equation out, and we had to put a specific value up front because that's what the leading coefficient is. All right, now for the mind-boggling, mind-blowing thing. Are you still here? Did you turn off the video? You're still watching the video? All right, I'm gonna click on problem number 1. I'm gonna show you something. I'm sure some enterprising student probably tried this because they said, "Oh man, can I just plug this in the Desmos and get the answer?" So here, I'll plug it into Desmos. X squared minus 4x minus 21. Now, it's very important when you plug it into Desmos that you put x and not v. Desmos won't graph v. You can put equals 0 or not. If you don't put equals 0, you get the actual parabola-shaped graph like we had been seeing on some earlier assignments. Take it or leave it. If you put equals 0, it makes 2 straight up and down lines, but it doesn't ruin what you get. And here's what I mean by what you get. Look at the zeros. Oh, -3. Oh, 7. Oh, those were the answers. Well, what do you know? The zeros, the x-intercepts on the graph, or also known as the zeros, also known as the solutions, also known as the roots. There's like a lot of words for this. What do we got? We got solution, zeros, x-intercepts, roots. That's how you get the answers. It's as simple as that. And even if I wrote equals 0, they still cross at -3 and 7. So, I mean, you can write the whole thing. I mean, it doesn't really matter. Here, let me show you number 2. X squared, 5x minus 6. Oh, would you look at this? We got -6 and 1. Notice it crosses other places. Don't mind the y-intercept, and you don't have to mind the vertex. We just care about where it crosses the x-axis. Those are the solutions. Even on number 3, let me show you number 3. In fact, I will not even rewrite number 3. I'll write it the same way it was written in the problem here. It makes the vertical lines if I do it this way, but that's okay. Now, here's where you got to be careful. This crosses at 3. Oh, look, that's one of the answers. And this crosses at -0.4. Now, I have my doubts that Alex will be okay with you typing in a decimal, so you will need to convert -0.4 into a fraction. And if you are familiar with using Desmos, you can type it in and click a little fraction maker, and it'll tell you what that is as a fraction. The only issue you're going to run into is if it's like 1/7. If let's say the answer is 1/7, right? Let me just mess with this problem. Let's make this 17. Perfect. Look at these answers: 3.772, 3.222. I guarantee you those are rounded answers because that's what Desmos does. It only goes 3 decimal spaces and it rounds. These are rounded answers, and if you change these into fractions, you're gonna be wrong. So this is not the way all the time. Sometimes this is not the way. Okay, so be careful. You can use a graph to find the zeros or the roots of a function. That's kind of the point of this extra segment here. All right. That being said, you might have noticed we skipped lesson 9.3, and that is why we skipped lesson 9.3, because lesson 9.3 was how to graph it for the answers. Now, of course, the book presents it as graphing by hand is so difficult, so it's way too much work to bother to do it by hand. And if you had no calculator to graph it on, graphing is the worst option. Don't do graphing. Do algebra. But if you have a graphing calculator, it's a viable option. If you're taking an ACT in the future and you're presented with a problem like this and you have a graphing calculator on hand, to type it in and get the answer. That's fine. That's fair game, says the ACT. Okay. All right. So just throwing that out there. Okay. So again, we had 6 problems of factoring and then using that to find the solutions. 4 problems of writing equations based on the solutions. And then at the end here, I showed you how to graph it if you want to graph it to see the solutions, which is a great way to check. Okay, we'll just check with that one. Okay, not use it to solve the problems. Right? Okay, right. All right, I'm done. I appreciate you watching the video, and I will see you on the next video. Goodbye.